We've arrived at part 5 of the endocrine system, page 605. Over here on this page, we're viewing an interesting presentation here of someone who is, how shall I say, hyposecreting the growth hormone from the pituitary. Here we have somebody who is hypersecreting the growth hormone from the pituitary. And here we have somebody who is sort of more standard in the balanced homeostasis, having much more natural proportions of the average individual. Okay, so there's variations on a theme, and our book does in fact discuss the idea here of in the homeostatic imbalance of giantism, and this could take place hopefully before maturity and before the closure of the growth discs and plates in the long bones. If it continues to happen after that, then there are some other difficulties referenced as acromegaly, which can be extremely painful and inflammatory. So there's that problem. And then pituitary dwarfism is the opposite of the giantism. It's the undersecretion, and so the slowing of the developmental pathways. Okay, so we move on then to thyroid secreting hormone. This is a pituitary. We're continuing actually now with the anterior pituitary, the adenohypophysis. And we had growth hormone, then we had TSH, thyroid stimulating hormone. It begins with hypothyroid, the hypothalamus, with the thyroid releasing factor, and that's going to initiate actions from the thyroid stimulating, which will go to the thyroid gland, which then produces thyroxine. So that's basically what we're looking at here, the star of this particular episode, because we're in the pituitary, is the TSH. That's the hormone that is present. It's on all the time. If the individual is not able to, for dietary reasons, for instance, not be able to make thyroxine because maybe they lack one of the ingredients like iodine, that's not going to stop the TSH and the TRH from continuing their stimulation down this cascade. And what's going to end up happening ultimately is that the thyroid will grow and not produce the wanted and final factor here, the hormone of thyroxine, because this is under negative feedback. Let's take a look here at the cascade. Coming from the hypothalamus, we have TRH, thyroid releasing. From the anterior pituitary, we have TSH, thyroid stimulating. And then finally, at the level of TSH, we stimulate the thyroid gland to produce thyroid hormone and go to the target. And then notice that we have this dotted line here, which represents negative feedback. So all of the solid arrows represent a positive stimulus. These are essentially excitatory, excitatory, excitatory. And then we have this feedback from the final product here, the thyroxine, and that's going to be inhibitory and inhibitory. Okay, so as long as you have the correct and balanced levels of the final hormone, the thyroid hormone, then we can turn off the higher levels of the system so that we don't overproduce the hormone. The same thing as heating your home. Once you have the adequate temperature, the thermometer arrives at that temperature, then you have a rheostat which automatically turns off the furnace or the central heating, whatever it is that's causing your heat to be produced in the home. So the same idea here. Once we get to the balance point, we have the correct amount of thyroid and it feeds back adequately, then these turn off. The problem, of course, then again is what happens if I can't make thyroid hormone because I lack, for instance, iodine? And that was the case of people who had moved away from the coasts here in the United States, or before during the colonial period, when people were living close to the ocean, and there was plenty of iodine from the earth being saturated by the debris from the sea, and so the soils were still rich enough in minerals that the food that was being grown did not cause difficulties. People could still make their thyroid hormone, but once they crossed the Appalachians, they were in a place called the Goiter belt, which meant that the soil did not have iodine. And so eventually we had to add iodized salt to our diet at one point, and that made up for it. So, and you can see what happens in the absence. The thyroid gland continues to grow despite the fact that there is not an adequate hormone output. And so this is referred to as a goiter. And it's often, as probably is the case with this child, the result of a diet that lacks the correct ingredients for the substrates to make what is needed to be made. Here now is the microanatomy of the situation. We have our bloodstream coming by, and we take up nutrients, and we also produce various parts of the molecules in the endoplasmic, the rough endoplasmic reticulum, and then ultimately in the Golgi apparatus. And we eventually get to the storage portion. If we take a look here at this preceding page, we can see that there are cells that create what's called a follicle, these ball-shaped or spherical-shaped follicles that within them contain a area, a vacuole area, in which there is a colloid storage form. And this is the gross anatomy of the situation. Okay, and so the thyroid gland is a little bit highly positioned here. I think it's a little bit lower than that, slightly. The reason is that I know that the clavicle is here and that the manubrium is here, and this has to be behind the manubrium. So if you were to stand behind your patient and place your fingers next to the sternocleidomastoid muscle where it meets with the trachea and ask your patient to swallow, you can feel down the trachea, and you should not be able to feel the soft tissue of the thyroid gland. That would be an indication. If you can't feel it, then that person does not have a goiter. So the artist here is sort of misrepresenting the position actually of the thyroid gland. It's a little bit lower. Okay, so at any rate, these cells right here are producing the colloid storage form. We actually have completely different cells over here called parafollicular cells that are producing calcitonin that have something to do with the uptake of calcium into the bone matrix. But basically, to look at just the cells here, we have the development here of a storage form. The storage form is actually the molecule with either one or two iodines. So the little sky blue balls here represent the iodine atoms attached to the polypeptide base. So we have dits and mits, the diiodo, two of them, and the mits, the monoiodo item right here with just the one iodine. And we can put these together, and we can make T3s with 3 iodines, T4s with 4 iodines. It turns out T3 is the active form, and nevertheless T4 is the one that's most often sent out into the bloodstream. So you can see that they're being delivered to the bloodstream here. The T4 will eventually get to the target organ, tissue, receptor, etc. And one of the iodines will be removed, and they'll come back over here, and they'll get incorporated into the next building of the tissue in the colloid layer. Okay, so T3, the active form, T4 is the inactive and sort of travel form, as it were. Okay, then So that's that little episode right there that has to do with this. We're going to be also remembering that we have follicle-stimulating hormone from the pituitary and also luteinizing. The follicle-stimulating hormone is specific, but I'll get to that in just a second.